In today's video, I do some experiments running a battery backup system off of these lithium motorcycle batteries, and I'm actually thoroughly impressed because I filmed this a little bit too tired, and I was constantly surprised because I thought this would be like their competitors, where they just have some lithium batteries and some supercapacitors in there. But no, turns out once I got all the potting compound out, this is actually just super high discharge rate, high quality lithium iron phosphate cells. I've never seen ones this good before. The build quality is great. Even the potting compound is very flexible, so that would lend itself very well to being knocked around or even dropped or crashed on in a motorcycle. I do a lot of off-roading anytime I'm doing motorcycling, so this actually appeals to me quite a bit, much better than the lead acid batteries. Now, I was a little bit too tired when I filmed this video, and I kept getting confused by that. So I'm going to try to edit out any of my kind of Alzheimer's moments where I'm like, I guess that's the supercapacitor doing that. Because it turns out this doesn't not have a supercapacitor. This has just really good lithium iron phosphate cells. I try it in a battery backup, a UPS, and it actually works out pretty well. I more of came up to the limitations of my UPS because it's only rated for 300 watts, but this actually did pretty well. So yeah, this is a pretty good brand. I'm actually really impressed. I didn't even know they made batteries this well for motorcycles. And it makes me think these are actually pretty useful for other applications. Well, here's the video. I've been ready to pounce on any company wanting to send me a lithium iron phosphate engine starting battery for a little while now. And finally Weize stepped up to send me one. And so now starts some experimentation, because with a high discharge rate, well, that changes some things. It might work for a battery backup. It might work for, let's say, running an inverter in short bursts for a power tool. Now, I already tried that with a welder, but it turns out the welder, it tripped my inverter, so that was a little bit anticlimactic. The battery didn't even really get tried with that. You could possibly use this to do like spot welding, because the capacitor will hold a set amount and you might be able to work with that. Well, I charged this battery in our little 30-watt window charge station that we have set up in our bedroom, and I'd say, since this says it's a 4 amp hour battery, I wouldn't expect the lithium iron phosphate module inside of here to give more than like 40 watts. So let's connect it up to this inverter, and let's have it run the center console, the TV, whatever it's called, of our living room. That should take about 80 watts. So with that light load, we can see at what point does the voltage dip down and the capacitors drain, and then we start taking from the batteries. You know, the worst thing about this is that it's never in the position that I want it to be in. It's always upside down. All right, so whenever I turn this on, the TV, the light, the sound will turn on. I'm going to turn the TV on to increase the power. Let's watch the voltage and current change. This TV takes forever to turn on. But it is getting warm. Should have had this ready, I bet. Oh, right, I had this sitting in the sun, being charged. Well, that's not going to be very accurate then. So we can just disregard that. What's nice is this is actually handling high discharge fairly well. Okay, I'm gonna turn this off. Why do they have the input on the left side of the screen? So every single time it always has to be wrapped around like an S. Because I don't have any instances where I have the battery on the left of something. It's just funny how that works. But yeah, no wonder this was hotter. It was in the window for like an hour. So next up on the experiments table is the battery backup, and that takes these connectors. So I had ripped apart a battery previously, and I just soldered one of my Anderson plug things strictly to that, so I can connect this to the battery backup without having to cut any cables that are important. This has been charged up a bit more, and let's see. Okay, we have this little monstrosity connected up. We have the UPS switched by this, and it's powering my computer. And we have some redundant voltage showing, metering. Now that we have this thing turned on, whenever I toggle this off to simulate a power failure, we can see the information. So turning it off. So that was 20 seconds, and I feel like it discharged the capacitors in about 10 seconds, but that was only taking 80 watts of power. Okay, let's get the Final Fantasy XIV Dawn Trail benchmark going. Okay, so let's do 10 seconds or until it goes to 12.8 volts. Oh, I heard a weird sound. Ooh, that was sounding really weird. Okay, we're not gonna count that. It's a little too much cabling, I think, going through that. The game's still running though, but boy, was that sounding weird. I believe that this power supply is only rated for 300 watts, and I believe we were taking more than 300 watts from it. So actually playing the game, while we're logging in now, let's see what we get. So it started getting that weird like sound after about 14 or 15 seconds. But we were pulling a good, what, 150? And that was while loading. Now that we're loaded in, let's do it again, just for redundancy. $160 watts. This game takes so much power, gosh. Still working. Okay, now it's charging again. There's definitely some bit of bottleneck with this wiring, so that's understandable. However, measuring on the system side of it, it wasn't dipping too low. Okay, so using it for a battery backup, actually it did exhibit some improvements. First of all, I believe the biggest improvement is just because most of the wiring inside of this battery is most likely very thick, and the BMS is also very thick. The other 12 amp hour battery, which I cut up to have this connector, it had like 16 gauge wire inside of it, and it was only able to provide, I think it was like 80 watts before it really dipped too low in voltage. But this one, even being only 4 amp hours, I feel like once the supercapacitor fades, the lithium iron phosphate battery is still allowed to give a lot of current. So an 8 amp hour battery or 10 amp hour version, which if they do sell, could work for a 300 watt battery backup for maybe 30 seconds. It might heat up a bit much though. It might be better just to find a way to fit a 50 amp hour battery onto this so then you could run it for a half hour if you needed. But that definitely does show improvements. I do have a generator which uses like a 10 horsepower motorcycle engine that I had thought about using this on, but that might be a bit big. And we already know this is going to work fine for engines because a supercapacitor actually is a really good idea, especially because with this, if you have a supercapacitor charged by a smaller lithium battery, then you wouldn't have that issue of starting it and then it winding down and not having more power in the battery. You probably get one start. If it didn't start, wait 20 seconds for it to fill up the supercapacitor, and then you can try again. So overall, this will work really good for an engine. I don't think I'm going to go and try to hook it up to the engine that I have because it's a little bit too big. Now, what's the next test we can do with it? Something that uses high load. Or we just open it up. I think we just open it up. All right, the computer's on. Let's turn this on. Now that's pretty funny. So this casting is obviously made for the lead acid batteries, and they just use it because it's, well, makes no sense to re-engineer it just yet. But this is where the valves go for the lead acid battery, because as it's used and as it's charged, it releases hydrogen and oxygen, and that can bubble up through these. So they have like a little upside down rubber cup. So gas can come out, but nothing can go in. And that's funny to see that. I suspected we would see that. Now for the more difficult part. So I just spent a good little while trying to get this open and made absolutely no headway. And you can see how serious I am about this. I have never used 2 Swiss Army knives simultaneously in my entire history of YouTube, as far as I can tell. And I got it cracked around the outside, but this is entirely filled with this material. And that makes me think that, judging by the stiffness of it, this is going to be almost impossible to open up. So that does kind of dash the ideas of using it, like taking it apart and taking the pieces out as a playing around kind of thing. This is really built for just abusing. So I guess I have to just think of something to do with it as it is, because I don't want to start tearing it apart and it ends up being a big mess and I have to throw it away, because that'd be such a waste. I do these videos so I can use this stuff. So now the question is there anything that can use 12 volts that this would be good at? I'm obviously very cautious because this is a high capacity battery. I think I got it. Oh, so there's two different types of potting. In general, I tend to think very highly of Weize's batteries, so I'm not let down. So they were using that to seal it up and make it waterproof. And it looks like it is actually pretty waterproof too. Now we have this, unfortunately. Let's see. Yeah, it can be. I wouldn't want to use this though. I'm going to rethink this, because can I cut this with plastic? Sure, but I could also cut pouch cells that are underneath there and kill myself with it. And it just went out. The BMS gave way, I believe. Obviously not meant to go for a full discharge, because it did just turn off instantly while I was standing next to it. It has been exactly, well, no, a little bit less than 2 hours. So it has been exactly 2 hours that this was running. So that's 4 amp hours, and it wasn't even fully charged as well. So that works. Now that this is fully discharged, I can feel safer about excavating it. And I can feel how squishy it is, so I can feel where things are. Like for instance, at the corner or the perimeter, it seems like there's not that much there. I got a little nervous because I knew I was getting near something, so I used this piece of fiberglass. Turns out there is a covering. I'm really enjoying the battery that is being revealed. Everything is where I expect it to be. And this is probably going to make this last a long time. It might also act as a bit of a heat transfer as well, besides the shock absorbance. I realize this cable is taped around the entirety of the thing, so even though this was bending it, this I can pull on the tape by pulling on this. Well guys, I removed most of the silicone, and as for this, we have 11.18 volts. I did shoot a little bit of sparks right at the end, but I didn't have the negative terminal connected up, so hopefully that limited any damage inside of this. So these are actually genuine high discharge, high C rating lithium iron phosphate. That is a little bit unexpected. I haven't seen anybody else online that's selling these. So getting the bigger pack might actually work with the battery backup. Finally got a lot of this stuff cleaned off. Now to clean this up and to figure out how am I going to end this video? How am I even going to edit this video? Because I started it thinking that surely this must be like all the other ones I've seen online where they have a supercapacitor, but it doesn't seem like it does. It seems like it's the other one where it's a high discharge rate battery. That is amazing. So it's been a few days and I think I've reached a good point to end with this. I was going to plug this into my battery backup and do another discharge and see how it heats up, but I'm a little too busy with other projects right now. What I'm thinking about for this is I removed the plugs. I'm thinking 3D printing a housing for it, and I might want to draw inspiration from the Nintendo DMG-03 Nintendo Game Boy battery or something like that. I have a company sending me a pretty fancy 3D printer, and that's coming in a few days, and that might be a good test for that. And then also I want your guys' opinions. Should I just have positive and negative output? I guess I could have that no matter what, but I would like the outputs to be shielded. But then also I would like to get a DC to USB-C high power circuit. So like I could charge my Vive XR Elite VR headset with USB-C, or I could run a laptop. Because I see this, this could run a 60 watt USB-C charging circuit. I should just see if I can find one that takes 12 volts. Because that's pretty cool. A little like step up boost converter. I have one somewhere. Found it. I believe this does 25 watts, but I think this needs 24 volts. I could be wrong. Actually, that might be good enough, to be honest. So I'll try to find a way to compactly fit this into a small box. And I'll have this on there as well. And I'll have these on the side, shielded, so nothing can touch these. Maybe even have a cover for them. But I would also like you guys' input on what's something neat that I could do for a style that almost looks like see, like I also like this kind of style, the 1980s style. Let me know if you have any bits of any sparks of inspiration. Well, this is a pretty high quality piece, and I'm gonna give myself some time to do something cool with this, because this could be my pocket battery for running a VR headset. Well, I hope you guys enjoyed this video. Thank you very much for watching. See ya. And thank you very much, Weize, for sending me this battery.